So actually the first thing I'm curious about is why am I here? Like what, because some people just kind of volunteer what's your interest in Mongo, and what's your previous knowledge of Mongo? People, maybe someone volunteer.
Nobody's allowed to say because I heard it's web scale. Just get that out. Let me just get that out right off the bat. Not allowed to say that.
I was going to just play that video just
That's actually your talk. 5 minutes, we're in, we're out, we're done.
I've heard of it, I just don't know much about it, so.
Okay.
I understand it's not totally NoSQL.
Well, yeah, I guess, I don't know. What is NoSQL? There's no SQL in it. But I guess we can talk about that at the end. Yeah.
Does it have a reliance on the schema?
Yeah, there is no schema in MongoDB. It's true. So that's one of the main things I'll talk about.
Because I typically have clients that, they don't know what they want. And so on the fly, 2 months after we're done, they come up with a better idea, so.
Mm-hmm.
That what it is?
That's happened to us too.
Mm-hmm.
But okay, that's good to know. We'll address that schema change issue at some point.
I'm always interested in hearing, in the real world use case, the impact on development. Do you hire new developers? Do you retrain?
Okay.
And then leveraging something like Mongo to have pseudo transactional capabilities. I know that
we don't really do. With CMS, we actually don't worry so much about transactions, which is one of the reasons we can get away with using a database like MongoDB. So that's good to know. Anyone else want to offer anything?
Don't forget Motorola, and you do CMS systems, and we're just looking to see what our scaling options.
Okay. All right.
We actually have a client that uses MongoDB.
Okay.
So my boss said, come back tomorrow and you're going to be the MongoDB expert. I said, sure, I'll have that by noon tomorrow. No problem.
All right. So basically what my talk is about is how MTV networks, how we leverage MongoDB for our CMS system. And let me talk about what I mean by that, if I can get this to work. So first of all, I want to
Just come in. It's okay.
say, well, actually before I do that, who am I? So my name is Jeff Yemin, and I've been working at MTV for about 6 years now. And so I'm in the platform group of online at MTV. So MTV is obviously there's a major broadcast component of MTV, as everyone knows. But the online division, where the website is like MTV.com and so forth, is a separate division. We work with the broadcast groups, but the technology group is completely separate. And within that, it's divided between brands and platform. So there's various different brands in MTV, which I'll go into in a bit, and then there's like a central platform group. And in that group, I'm responsible for the back end of our management system. So what do we do? So MTV Networks is actually quite a big organization. MTV.com, I guess, at one point was our flagship station, but since then, through acquisitions and growth, there's just a huge number of websites and stations that we operate. So some of the ones you might know: Comedy Central, Daily Show, Spike. That's like in our entertainment group, and then we have Kids and Family, which is the Nickelodeon properties, like Nickelodeon.com, Nick Jr., and also Parents Connect. And then there's like the music side, which is MTV.com, VH1, MTVU, CMT, and then there's like tons of other sites. So there's probably like a couple of hundred sites altogether. These are some of the major ones, and it's all part of Viacom, so that owns MTV Networks. It's I guess a fully owned subsidiary. So that's what we do. How do we construct our websites? Well, as you might imagine, it's complicated. Partly just because of historical reasons, and partly because of acquisitions. We develop a huge range of we use a big range of technologies for application development. So just in terms of front end, we do everything from Java JSP tiles to Grails to ATG Dynamo, if anyone's heard of that. We've been long-time ATG Dynamo customers since one of our very first websites, and we still use it. A lot of sites run on PHP now. There's even there are some on Ruby on Rails. It's not the most popular thing in MTV right now, but it's a huge variety. So what makes them all similar is that they all use some sort of content management system. So all of our websites are, well, to a greater or lesser extent, I would say our websites are all driven by producers. So we call them like they're web producers, and they use our CMS tools to basically produce the websites on a daily basis. So that's part of it. So there's the front end for the producers, where they're basically responsible for scheduling, entering and scheduling content, and then on the back end, the CMS also serves the site. So say the Grails site or a PHP site reaches into the CMS for data to render the site. Any questions? Obviously, just pipe right up, raise your hand at any time.
You say you keep referring to the CMS. Is there a giant platform CMS where all articles and media and content gets stuffed into? That is the MTV content management system.
So let me talk about that right now. So a brief history of CMS at MTV. I would say we have 2 successful CMSs built in-house over the last 12 years. The first was they're both still in use. Nothing ever dies in the enterprise. For people who've worked in the enterprise, you probably know that to actually kill a piece of technology is extraordinarily difficult. So every single CMS we've developed is in use somewhere. And there's a constant effort to migrate to the next CMS that's going to solve more problems than the previous one. And we also obviously fix the ones we have, but let me just talk about 2 of the major ones that have been developed. So the first is a traditional RDBMS application where it was built in Sybase. Now it's on MySQL. And it's basically like a store procedures, tables for all the entities, and then like a custom built application for that knows about all the store procedures and renders things about articles and videos and episodes and all that stuff. And yeah, go ahead.
You mentioned that MySQL replaced Sybase.
Yeah.
What was in Sybase, or what is in MySQL which is better than what Sybase had?
It's free.
Nothing else?
No.
You don't have to type go after every statement.
That's good.
You don't use the semicolon in Sybase. You get a carriage return and you type go and then you get a carriage return, much like
that's funny.
Microsoft SQL Server.
No, I'm actually not the person to ask about why we migrated from Sybase to MySQL, but from my understanding, it's a consolidation and cost savings. I think there's things we like about Sybase and things we like about MySQL, and we just kind of learned to live with it. I wouldn't say that the move to MySQL was a strategic move to get certain features. It was more about consolidation and cost savings.
Is that wrapped by like some kind of SOAP or REST web service that your node sites consume out of, or
No.
you literally just reach in and grab a library?
At this point, with the CMS, we were on a single presentation platform. It was all ATG Dynamo. So there's a manager interface, of Java-based manager interfaces for all the main entities. So it was all very Java-based, and there's no to do a PHP site on top of the CMS would have been very difficult to do. So anything else about that? So, and I wasn't around for when this happened, but the second major CMS that was built was kind of, from what I have heard from people who were there when it was built, who are still at MTV, is that what happened with the first CMS is that there got to be a huge number of, or not huge, but a rather large number of tables and an even bigger number of stored procedures. And the cost of adding and changing the stored procedures and adding new tables for every new entity for a CMS type system grew just to be too expensive. So, for example, like the one I always use is like Parents Connect wanted to add a recipe hub for their site. So to do that in the CMS would involve like creating the recipe tables and then the link table for the ingredients and the steps to do the recipe, and then create the store procedures to do the CRUD operations, then create the Java management interface to call the store procedures, and then build a custom UI on top to enter the recipes. And they really want to do this in a week. They're like, we want a recipe, the producers are like, we want a recipe hub and we want it up in a week. And what I think was recognized was that the overhead of, at least the way we were doing database development at the time, not to say that there's not ways to do this, because you guys are familiar with a lot of them. But at the time, the feeling was that we could do this a lot simpler, that we're not really gaining anything by having all these stored procedures and these tables. We could do something a lot simpler that's going to let the brands who want to do stuff like this move much faster. So we built a system, and we just called it CMS actually. But it's basically, the technology side, it's an RDBMS-based cloud store, XML cloud store. So there's basically like one table called like CMS item. There's more than that, but which basically has a few columns that you can search on, like URL key and content type, and a few others. But then most of the data is just in an XML cloud. And
So you have essentially like a tags attached to each long XML stored as a blob or as a CLOB.
yeah, exactly. And in terms of what the schema of each of the CLOBs are, excuse me for a second, is that it was managed at the application level. So we basically had in the presentation tier there was, I shouldn't say the presentation, the application tier, there was an XML configuration file that said all the different content, what we call content types, and all the different properties of those types. And then so if you wanted to add a recipe type with the system, all you needed to do is basically go to that configuration file, say like content type recipe, ingredients list, steps list, tags. You deploy that, and then on the tools side, we basically had I guess what we call a table-driven UI, so that would read this configuration file and dynamically create a UI that would render a recipe type. And I don't know how many people have dealt with this sort of system. There's there's trade-offs there. Like the good side is that it's pretty easy. It's very fast to get this up. The bad side is it's hard to customize. So we built some customization options so that we could somewhat customize the way the recipe page appeared to the web producers. But for the most part, it was pretty fixed and table-driven. And then on the application side for actually reading this data, it was also a Java-based system. So we were still at that point, everyone was doing Java. So there was a Java API that gave you access to this backend database, and there was an ORM system. So you would actually have to create a recipe class in Java, and it would dynamically map the XML CLOB in the database to the recipe object. And then on the application side, you could do things like get me all the recipes and so forth. So that's how it works.
Did you use JAX-B for converting?
No, that's probably I don't know if it preceded JAX-B, but we don't use JAX-B.
Was there like just a base automatic class for a generic object? So you could specify in the XML what you want it to have? And
no, we didn't have a map. There was no it wouldn't produce generic maps. I think the idea was that these were kind of business objects, and we could attach behavior to them, so that you could do things. You could do things in the recipe class more than just a straight CRUD type operations. But in practice, they didn't end up getting used very much. So as you'll see, I think we decided with our new CMS that it was more trouble than it was worth, and we got rid of it. Any questions? So I think what we found is that the second system, I would say, was more successful than the first in the sense that it allowed brands to basically do what they wanted to do really quickly. So it allowed them to innovate more rapidly and build websites that they couldn't have done in a cost-effective manner with our original CMS. So in that way, I think that it spread amongst all the brands. It started, I think, with Nick Jr. was the first one, but then pretty much every brand at this point has built sites on top of the system. And for the most part, like development of the first system has been in maintenance mode for years. Like we don't really add new content types to that system. And all the new development is done in the CLOB-based CMS. Okay. Why does it keep doing that? So, what are the problems with these systems? Obviously, we felt like we needed to do something more than what we had. So, we should go back. Think about what the problems were with the CLOB store. Can anyone think of anything?
How do you search on CLOB? Or how do you do it?
Exactly. So we had these sum columns that you could break out, but it was a fixed set of columns. There was URL key, and we had a category system because back when this was first developed, most of our sites followed a very hierarchical model. There was kind of, you could look at the site as a tree, so we had this category structure that we did have that as a first-class object in the CMS. So if you wanted to navigate in this tree structure, it was fine. But say you wanted to do like a tag cloud. There was no way to do a tag cloud. You couldn't even search and say, find me all videos that are tagged with Obama. There was no way to do that. So you were limited in what you could do in the sites. And what do you think we started doing?
You had more than one text.
Indexing it? Building index tables in a...
No, we use Solr. So basically what we started doing is exporting all the data to Solr. Exporting all the data to Solr.
Which is it's like Lucene. It's like a text. It's like unlike Sphinx is another product like it. It's text search engine.
Mm-hmm.
It's built on top of Lucene, but it's a REST-based managed. Well, it's not really a managed service, but you deploy it as a web application as opposed to as a Java library. And so basically, then that kind of unshackled everyone because basically they're like, well, we can reach into this content and put it into Solr and basically build our sites however we can do whatever we want because we can. Solr is flexible enough that any search that you can imagine, most of the searches you can imagine, you can do in Solr. So,
and to be clear, Solr itself was NoSQL before the NoSQL because it's a document-based store. Is it document-based? I keep forgetting between like Lucene, Solr, and Sphinx.
I'd say Solr is document-based. It's not document-based the way Mongo is. It's kind of flat. Like you can have properties and lists. You can have single-value properties and lists, but you can't have whole tree structures. But you can do a lot of interesting things with Solr. So we use it we build tag clouds from Solr. We use it as an aggregation point. So like we do things like if you go to the Daily Show, for example, we do things like let me show you this. So on the Daily Show, we have like a videos page.
This is what we came to see.
Yeah, Jon Stewart. We should have a videos page. So there's like a tag cloud, but if you go, you can see here that if you want to see like Stephen Colbert, we can search on the tag. This is like a tag cloud over here, and then you can search on most recent videos tagged Stephen Colbert, but we're doing sorting on recentness, which is not so hard, but then most viewed is the interesting one. So we have a whole different system for storing view counts. There's basically beacons in our videos, and whenever a video is viewed by anyone, the beacon fires and we track every single view of every video. The problem is, how do you do something like find all videos tagged Stephen Colbert sorted by view count? If they're in two different systems, you really can't do that. So we use Solar as like an aggregation mechanism to bring those two together. And then once it's all in Solar, we can do things like this kind of query. Like that's Solar is basically driving that query. So that has worked pretty well. The main issue with Solar that we found is that getting the data in is kind of painful. So we have to basically do these big feeds from our CMS into Solar, and sometimes the feeds fail, sometimes there's longer delays than the producers would like. Basically, we're just moving a whole bunch of data from our one CMS, where all the data really is, but you can't search on it, and we move it into this other system. So it's like constantly piping information, like boom, 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 just to create a Solar collection. So we have these like incremental feeds, then every hour we run the full feed, and then you only get updated view counts when you have the full feeds, so things tend to lag. So generally, like using Solar has been good, but we felt like technology has progressed in the database, in the NoSQL space, as I'll talk about in a minute, where we could do this stuff right in the CMS. We don't need to have a CLOB store and then move everything into Solar. How do I make this better? So, what are we trying to do? So, what we were looking for, so basically we still felt we needed to build our own CMS. I'm not going to go into why we didn't purchase a commercial CMS system. It would take too long, but what we did need was a repository to drive our CMS. So what we were looking for, obviously, scalability, stability, and speed were very important to us. Our websites, they can't really be down. People get very angry when our websites go down. So we needed to be up all the time and needed to be fast. And we need to scale in a bunch of different ways. Like we need to be able to scale with, fair amounts of content, although we actually don't have that much content if you from perspective of like really big database. Like we're not like Facebook where we have like tons of profiles. We're really just like, we have a bunch of shows and videos and some commentary about them. So it's like, we're talking like gigabytes of data for each site, not like maybe hundreds of gigabytes, but we're not talking about terabytes or petabytes of data. So we didn't need to scale that way, but we did need to scale in the sense of like, we have a lot of sites and we want to be able to manage like 100, 200, 300 websites and be able to scale that both operationally and performance.
For bursts of activity, I don't know if you guys have a popular video, something that gets viral. Is that a consideration as well?
Well, we have a lot of layers of caching, so we've been a long time Akamai customer. So we survive on Akamai. You can say like we've consciously not built out our origin to handle actual load that's being placed on us from users.
Does your origin, is it from your CDN, so Akamai gets the request and then populates its nodes from that, or do you actually have some interface into Akamai where you start up with them?
We do both. Like for certain things, like for video, like the actual videos, I think we push them out to the edge proactively, but for just pages like that Daily Show page, like that's basically, the Daily Show is Akamai and it goes to origin. And then, so that's how we handle the kind of like when Michael Jackson died, or when like VMAs are a big thing for us, Video Music Awards, all sorts of things like E3 on game trailers. There's KCAs. There's a lot of our traffic is driven by these events, so we do have to handle these loads. But typically we do that by with edge caching.
Does your content expire, like after a period of time?
It depends. There's certain content that does. We have certain contractual arrangements, like particularly with our music videos, because we don't own those videos. We just license the right to show them. So those deals, any deals we have with the labels, we have to obey like those windowing periods. But a lot of our stuff just kind of naturally ages out. Like if you look at the Daily Show, like I think you can find every Daily Show episode since the beginning on thedailyshow.com, but you'd have to dig more for the older ones. I don't think we actually expire the old stuff. We just kind of keep it around, but it just doesn't. It's no longer on the home page. The view, just no one's looking for a 2008 election tag anymore because it's things like that.
Yeah, so I think my question was, do you have archival? Because sometimes you have a situation where older data stops the newer one from being efficient enough in being served.
Well, as I said, we don't have like that much content that we have to worry so much about moving stuff off the main server farm to make room for the other stuff. It could happen. Like we have some UGC, like Spike Spike and Game Trailers actually both have quite a bit of user-generated content, so that maybe we have to worry about more. But for the stuff that's driven by producers and by the broadcasts, it's not enough data that we have to worry about.
The system, the new old CMS system where you have your content systems, and you push the content up to your aggregation system for the tagging and the searching, and then you put on your site based off of that, or is those just keys back into the CLOB system to pull?
It's a little bit of both. People kind of do different things. Some sites, I think, pull more from Solr. What I know that we're trying to do now is just kind of minimize our use of Solr. So we do it for what we like. Our ideal state is that we use Solr just for what we call search, like keyword search, like the search box. But then all the data access is driven by the CMS.
Yeah, it's just very big company. You might have legal issues where you have to take something off your site very quickly.
Yeah, I think it's hard for things to get taken off immediately because there's so many layers of caching, it's on the edge. So to get something down, it just takes a little while to really get something totally cleansed from the system. And it's happened. I think we had some I don't remember which one of the music labels basically said we can no longer show any of their music videos, and it was a huge headache to get thousands and thousands of videos on every one of our websites. So it does happen. So, what else are we looking for? So we still felt from the new old CMS, we still like the idea of having a client-defined content model. So we didn't want to have manage a database schema. We wanted to have it be in the application tier that we manage our content types to give us more flexibility and more speed of development, hopefully. In terms of what we want to express in that model, I would say it's hierarchical and linkable. So if you imagine say a music video, a music artist, and a music genre, you can imagine that there's links between all those things. A music video is performed by a number of music artists, and music artists is in some number of genres. Same with episodes and videos and shows and series. We want to be able to link them all together. But then what we would call individual content types should also have the ability to be hierarchical. So you should be able to say that an episode is tagged with a list of tags. And then even within that, you might want to be able to say things like a series has a list of people and have both links to the people and also sort of metadata about the link. So maybe I don't know, Hannah Montana is the star of this particular series. So we want to be able to express, so you can think of it as kind of like a tree structure with cross links, forests with links between the forests. And everything kind of can point back and be circular.
But it also looks like joint, essentially.
I guess joins is a way of pulling the data together. So we'll talk about this more, how do we, given that we have linked content, how do we deal with, how do we do our queries in in a system like Mongo. So we'll talk about that. So queryability is obviously important. That's one of the big problems I said with our the CLOB-based CMS is that we couldn't really query it. So you could query an URL key and categories, but that was pretty much it. So we wanted a database or repository with a rich query capabilities. And last thing is operational efficiency. So we wanted a system where it was easy to manage. So like, and one of the aspects of that is we were looking for something where our DBAs could keep playing the traditional role they've had in our organization. So we have a separate DBA organization. We also have a sysadmin organization. The DBAs are responsible for MySQL, and they handle database administration, backup restore, monitoring, review, capacity planning, kind of stored procedure review. We wanted to maintain that because we felt like they already have a team, they already have a 24/7 support organization. Our application group does not, so we wanted to be able to leverage that as much as possible. And so we wanted a system that made sense for the DBAs and also made sense for the application engineers. Any questions? So, here's my little joke about web scale. So I'm not gonna. There are obviously a lot of different technologies we could have chosen. There's Solar itself. There's React. There's Cassandra. There's a lot of different things out there. There's MySQL. It's just, so I don't really have time to talk about why we chose Mongo. Maybe at the end we can talk about some of the alternatives. It would just kind of take too long. But I'll tell you that we did look at a number of different systems, and Mongo just kind of hit the sweet spot for us, and I'll talk a little bit about why. So in terms of scalability, what Mongo brings is something similar to what MySQL brings, I think, that you have in the sense that we're thinking about it. So in Mongo, there is this notion of a collection, which kind of maps it maps most closely to a table in MySQL, but not exactly. So you can have collections, and then collections live inside of databases. So a database is a bunch of collections, and then a replica set is a bunch of databases. And a replica set is basically like a cluster of MongoDB instances with a master and a bunch of slaves. And the only difference, I think, from what you might be used to from MySQL is that the master can change. There's automatic failover from master from the primary to a secondary if the primary needs to step down, or if it goes down hard, secondary. There's an election process in the secondary.
Is it bidirectional? Is it bidirectional? Is it like secondary or primary? Like, can you write to either one, or?
No, you always write to the primary. So you always write to the primary, but the primary can change, and the application will dynamically discover that there's a new primary, and start writing to the new primary. So proven stability. So we've just found, like, just from our own testing, we found that Mongo has been quite stable. And I'll talk about some of the live deployments a little later, but it's relatively simple to understand how it works, and it hasn't really crashed once, so that's good. And speed, Mongo has a reputation for speed for a number of reasons, but basically what gives Mongo its speed is that you can, when you're doing queries, at least on the read side, you can add indices to essentially any property in your document. So if you have a bunch of episodes and you have tags, you can put an index on tags, and then when you do search for tags, you'll use the index, and it uses B trees for its indices, and the queries are very fast. I think like any database, and obviously your mileage varies with different databases. I think this is maybe a misconception about Mongo, perhaps, that it has to be in memory to be fast, but I think it's actually more like any other database that you might think of. Is that it's always slower to go to disk than to go from memory, no matter what. So it's basically, is your working set does your working set fit in memory? And if you're constantly thrashing and paging to disk, then your queries are going to be slow. But as long as your working set can fit, your performance will be really good. So the tricky part is discovering what your working set is and how big that is, because it's sometimes hard to know in practice what your working set is until after you launch your application. So it's good to have some breathing.
Does it actually write a physical file for those indexes like MySQL will do?
Yeah, it's all. So Mongo is it's not like Memcache in this. Like it's actually everything is backed by the disk. So it uses memory map techniques to do this. So basically, you have your files on disk, which represents your store of documents and your indices, and they're paged in with memory mapping to RAM, and then that's used. And so it's really simple. The code is actually, I think, pretty simple in that it's just if you need to use an index or something that's not in memory, it just accesses the memory and it brings it in from disk. And things that aren't used will be paged out according to basically the way Linux OS basically controls that. Okay. Let's see. So, in terms of the picture, I think Mongo. I think in version 1.4 or something there was master-slave replication, but I think maybe 1.6 they started with replica sets where there's a primary and the two secondaries, I think you can have up to 6 secondaries, and the limit of size of a replica set is 7 nodes. Okay. So, client-defined content model. Well, kind of by definition in Mongo that its client model is content-defined because there's no schema. I said that a collection is the closest thing to a collection in Mongo, in MySQL, is a table, but it doesn't have to be that way. Like you can essentially put in a collection documents of any structure, and the structure doesn't have to be the same for the documents in that collection. So you can basically put anything in there. You can use collections more like tables, where you could say that, well, all my episodes go in this collection, all my tags go in this collection, all my series go in this collection. But you could also put them all together, and that's actually what we do. We put them all in one big collection. I'll talk about why we do that. So what does that? That means basically we have to manage the schema on the application side. And we do it similarly that we did with our old, I like that old new CMS, our new old CMS. The only difference the way we do our content types is that's different is we actually store the content types in Mongo itself. So we have kind of a configuration collection or database in Mongo where we store things like our content model. So
now, does that work with your kind of half centralized, half decentralized? Like, we'll give you a CMS, but you deal with the types and things like that, so that someone doing a recipe can deal with their recipe types. Is that kind
that's
of
the idea? Is that you can actually upload a new content type or schema through a REST interface. So if you want to add a recipe type, you just write some XML with your recipe type and you upload it through the REST interface, and then it's available. Now there's a tension there, and if I have time, we'll talk about that. Is tension of at an enterprise, at the enterprise level, how much are we concerned about having a unified content model across the enterprise? And I think one of the things we're trying to do in this project is promote unified content models, and by having a centralized CMS, it helps us achieve that goal. One of the things about the new old CMS is that everyone had their own deployments. So all the different brands deployed their own CMS with their own content models. So everyone had their own video type, their own episode type. So it was very difficult. If you think about, we have like a syndication business. So if you think about the syndication team, they have to deal with 7 different video types. And now, so that when they build feeds for, say, Sprint or Verizon for syndicating videos, they have to figure out how to map from 7 different video types into the schema that they've agreed on with their partners. So having a unified model really helps us for For syndication, also helps us for international, because we have like international versions of sites, and that's run by a different business unit. So it helps them to, if trying to consolidate on their side, it helps them to build sites more efficiently and more economically if there's a standard content model. So there's a bit of a tension there, I think, between wanting to have everything centralized and managed centrally, and also giving the brands the freedom to innovate and do new things quickly. It's something we talk about a lot. So hierarchical linkable content model. So it works out. Mongo is actually very well suited for this sort of content model because it's a document store. Anyone know what I mean by that? It's basically storing JSON documents. So anything you can do in JSON, you can put in Mongo. It doesn't store it as JSON text. It stores it as something called BSON, which is binary JSON. The only reason it's not compressed though. The only reason they're doing that is so they can. There's basically pointers within the BSON, so that if you want to reach in to get one property or set one property, you can do that. So. And so, for example, just like to do the equivalent of like select title for video, that's not what it looks like in Mongo, but you can do something similar. With BSON, you can look at essentially the index of that individual document and reach in and get the title without having to scan the whole JSON document to find the title. So it makes things like finding individual fields within the document and both forgetting and setting really fast.
And that's instead of those big CLOBs in the middle of the database,
yeah,
right?
Yeah. Basically, well, it's kind of that, so you can reach in more easily as opposed to the XML where we have to parse the whole thing. And then the indices also let you find the documents that contain the thing. So if you have an index on tags, you can find all the documents that are tagged with Obama, and then if you only want the title of those documents, then you can reach in and get the title really fast.
But you can't search on the elements within the JSON-B. You have to search. You can't query across those sub things. It's once you have the record, you can then jump to a pointer anywhere within the record, right? Like you said, you search for tags on Obama. You wouldn't search for the text Obama in the element name field. The serialized JSON object,
Yeah.
you can't search for items within that because that's.
Well, you can.
It's just a serialized object, right? So you can't search. You can't index on like a part of that. It has to be the entire thing, right?
No, you can index on. So, for example, I think of an example. So the simple thing is like you have an episode and it has a title. So you can put an index on title, and you can say find, and it's exact match for the indices. If you want to do like kind of fuzzy matching, you have to build your own thing. But if you want to say find the episode, let's say episode number, because you're more likely to know the episode number. You want to find, you're looking for the episode with number 101. So you put an index by saying collection.ensure index episode number, and then you could do a search for like episode number : 101. It will find any document in your collection that contains a field named episode number with the value 101. So that you have like kind of a logical pointer to that document, and then there's the kind of select part of the query where you can either return the whole document, that's like the default, it's essentially like select star, give me the whole document back, or you could pull sub pieces from that document back. If you only want to know the title of those episodes, you can pull the title. You can also pull the tags and get the whole list of tags. There's also something it does, which I can't remember what the name for it is, like if you have a list of tags, like a JSON array, when you do a search for like tags : Obama, it basically returns any document that has a tags field that contains at least one element whose value is Obama. So it's not like you're not like searching for a document that contains an array, Obama, Clinton, McCain. You're searching, you can do that with $all, but for the most part, what you're searching for is some value within that array.
Do you send your requests in JSON format as well?
Yeah, you do. So everything, because JSON is pretty flexible, so they just found that even the commands that you send to the database can also be expressed in JSON. So it's passed over the wire as BSON. So there's a little wire protocol they've defined called, I can't remember what it's called, but it's based on BSON with a little bit of sugar to like say like this is a command. But it's all JSON. And then for embedded identifiers, you can basically store links. So every document has an ID, and you can, if you want to link two documents together, you can have a field which contains the ID of the field of the document you're linking to. So that's how we handle the linking structures. So queryability in Mongo, there's a wide variety of queries you can do. You can do field level queries like episode number. You can do arrays like tags. You can search for embedded things. So if you have like user and then address, and then within the address you have street, city, you can do things like you can put an index on address.city, so you can reach in. You can both index and search on embedded things. So that's one of the things, like when people talk about how do you survive without joins in Mongo, that's one of the ways you do it, is you embed as much as you can in a single document. A single document can be, I think, 16 megabytes, so they can be pretty big. The idea is that you want to put as much as possible in a single document. And I think one of the mistakes people make, and one of the mistakes we certainly made at the beginning, is doing too much linking and not enough embedding. Which makes it more painful not to have the joins. The more you embed, the easier it is to do queries that don't require joins. You can also do sorting, skip and limit. There's query operators like and or, and in and not in, and so forth. There's plenty of documentation about that if you're interested.
What's skip?
Oh, just like
offset. Oh, okay.
Like you can start at 50.
Yeah.
Do you have like aggregate functions?
There's some aggregate functions. Hold on. So there's regex and what's called lm match. So lm match is interesting. It's like lets you match properties of an embedded document in the array. So you can say like, find me all users with where the zip code, where there's an address where the zip code is this and the city is that. So it's kind of, but in the same subdocument, because you might have an array, say you have an array of addresses, you want to find a single address that has both the zip code and the city. That's what element is. There's some aggregate functions you can do. There's some group by. There's also MapReduce, which I don't really have time to talk about, but you can do some aggregation with MapReduce. They're adding an aggregation framework in, I think, 2.2, the next major release, which will let you do some stuff like MapReduce style things, but without having to do MapReduce. So like right now, for example, to do a tag cloud, you can't really create a tag cloud in real time. You have to do some sort of pre-processing to do like a MapReduce to count all the tags and then create a transient collection which has your tag cloud. So I think they're going to try to add some more features that let you do things like tag clouds with a sort of minimum of effort.
What is regex?
Regular expression.
Oh, okay.
So one nice thing about Mongo, like more traditional databases, like the indices are optional. So you can do a query on any property, and there's been some bugs with this, but you should get the same results back whether you have an index or not. It's just faster if you have an index. So you can do it, if you want to do something that's a table scan, you can. And in fact, there's cases where we do this all the time, like especially with where we're doing queries with multiple conditions. Like we'll do things like find what's something. Like we'll do things like find the document containing like Obama with content type of episode. So we basically will, as long as the index covers one of the conditions, and that's fairly selective, you're in pretty good shape. So a lot of times we'll think through it that like, oh, we need another index, but actually the existing indexes cover the query adequately enough so that the query is efficient. And also, if your collections are very small, here's a good case, like series with looking for all series where which have a link to this person. We might not have an index on person because on the person link because we don't have that many series. There's only like 100 series on a channel. So just having an index on the content type is enough to narrow it down to 100, and then you can just do a serial search for this person within that small range of documents.
Are you going to talk a little bit about administration of Mongo later?
A little bit, yeah.
Well, for that example, does Mongo have something, statistics or anything to give you the insight that you might want to create an index?
Sure. There's a couple things. There's a slow query log that you can enable. So it's like a profiler. You can give it a threshold, like just tell me any query that takes more than 100 milliseconds. I think there's a way to start Mongo where it won't let you do a query that's not covered by an index. We don't use that for kind of the reason I just said. Sometimes we have collections that are so small we can make indices. There's also explain, so it'll tell you what index it uses. So Mongo has a little easier time than, because of the lack of joins, Mongo has an easier time of doing explain than a relational database because
Explain.
well, it's basically like choose an there might be 3 indexes that it could use, and it basically has to tell you which one to choose. And the way it actually does that is it's adaptive. So when you do a query, the first time you do a query that is filtering out certain fields, it'll actually run parallel queries on all the indices that could possibly be used and see which one returns fastest. And it'll redo this every so often to make sure it's still right. But then once it finds ones that returns, it kills the other ones and then the next time it queries, it knows just to use that index. So it's like adaptive. But it doesn't have to do stuff like joining across 6 tables, so which index do I use? It's pretty simple.
So once you've gotten a fairly large data set, let's say you're dealing with a 200 gigabyte data set, and then you're finding out through your slow query log or whatever tool you use that you have a particular one that's being run often, that's still very slow because it's not indexed. So then you go, okay, well fine, I want to add that index. Can you do that live?
Yeah.
It doesn't do like what MySQL would, which is lock the table and all that stuff. Can you do it in place?
Well, that's interesting. We actually got surprised by something. So there's a couple of issues. Yes, they added in a couple of releases ago background mode for index creation. So it's not the default, which is weird to me, but you can if you say ensure index on say tags and you say background true, it'll build the index in background and it won't be blocking on the primary. So the problem is that by default, the clients always read from the primary, so the secondaries are basically for failover. We're originally designed just for failover and for for high availability. So if your master primary crashes, your secondary has the data. But they added recently the ability to read from slaves as an option. So essentially on your driver, you can say slave OK, which means you can read from your slaves instead of, it'll read from slaves in preference to the primary. The problem is right now, when the index is replicated to the secondaries, that is blocking, even if it was created with background true on the primary. So that really sucks. So there's a bug report in for that, which we would really love to see fixed.
And just to follow up, so how long would it take to create a new index on a 100 gigabyte?
I couldn't even tell you.
Are we talking 10 minutes, 2 hours?
I've seen everything from 5 seconds to several hours. It depends on what you're indexing. For example, if you're just doing a simple thing like episode number, and especially if sometimes it's the case that a lot of your content in your collection doesn't even have an episode number, so it's skipping most of the documents. That can be really fast. But we do some full text searching using Mongo. So what we do is we build a words array. So every time we save a document, we look at all the fields and we gather a set of all the words and all the fields. And we put in an array of words. And especially if you have a lot of articles in your document, you have a lot of words, that index can get pretty big. So if you have to recreate your index on words, that can take quite a long time. So it's better for things like that to create your indices in advance before you have a lot of content, so that they can kind of incrementally grow as opposed to.
And you can't create the index on like the secondary master and then promote it to become
There's ways to do it, but it's a pain. It's an administrative pain in the neck.
Thank you.
This is why it's hard to go from MySQL to a different one, because these are the ways that we do things in MySQL.
Right.
And so you naturally think, oh, well, if you could read from the slave, well, then you can do this and that, and then it doesn't necessarily fit the paradigm.
Yeah. No, it's definitely different.
But even in MySQL, if you think about adding indexes in advance, you can save a lot of time on that.
Yeah. It's a trade-off. Like if you can make it so your database is offline to start, it's faster to create the index after, of course, and it's more efficient because it'll kind of compact it properly. But if your collection is live, then that's when you have more of a problem. So we do stuff like at the beginning of a project, we might import like 2 million documents because we're putting a new site on our system. There we'll just we'll import them, then we'll create the indices afterwards because it's not live yet.
So other than creating a brand new site, I would think with your content that you wouldn't be doing anything that creates a lot of inserts. There's not a lot of insert traffic, so therefore you don't really have to worry about the performance of inserts because of lots of indices.
In general, it's a question more of shared infrastructure. So if we're trying to save administrative costs and licensing costs by having larger instances of Mongo that have multiple databases, you might have a live database and one that you're doing imports on in the same replica set. So, because we're not creating a new. I'll show you later, but we don't create a new replica set for every site. We're actually sharing replica sets for multiple sites, so we don't have to have like 100 instances of Mongo times 4 replicas. So we're having like clusters of replica sets organized by brand. So we do still have that problem.
Okay.
So operational efficiency. So how does it work? And I'm actually comparing this not so much to MySQL, but before we chose MongoDB, we were using a different repository that didn't work this way, and it didn't work very well. So I'm more contrasting it to that. So what we like about Mongo is almost like in the ways it looks very much like MySQL. In that it runs as a separate process. It's not like you have a single CMS that's running as a process. There's a wire protocol, so our CMS application, which is written in Java, communicates with Mongo just over TCP/IP. That's the only thing. That's the only protocol you really have to worry about. The rest of it is hidden by the drivers. The clustering is really simple. Like you can set up a replica. I can set up a replica set. I'm not. I probably couldn't set up a MySQL master slave replication, but with Mongo it took 10-15 minutes to set up a replica set. There's no clustered storage requirement, so that was pretty important to us. So the replicas, the secondaries and the primary communicate with each other over TCP/IP as well. You don't need any sort of shared storage like NFS or SAN. So it makes it easy to scale it out. You don't have this, that's more of on the sysadmin side. With the previous product we were looking at, we had the shared storage requirements. So we had to have NFS and DRBD and all this. It was a real nightmare. So we like that.
When you say scale that, you scale to 6 nodes.
Yeah,
the maximum.
We actually haven't needed to use 6 at all.
Well, because you can only use them for failover.
No, you can. We use slave OK, but what we found is that we do read from our secondaries.
It locks when you index.
Yeah, we are careful with our indices basically, and we're going to look into maybe moving to the primary when we add indices. So we read from the primary or bring there's various things we're looking at how we're going to deal with that.
Oh, it's only when you add it while it's creating the indice, not on like an insert into the table.
Yeah.
A brand new indice, it will lock. Okay.
Yeah.
For reuse.
Because it's only when you're creating an index and there's already a lot of content, that's when you have to.
Right.
Is there a reason that if you could foresee the need for an index, is there a reason why you wouldn't just create indexes on everything that you could?
Sure. Well, why?
Aha, an Oracle developer, I see.
Then it becomes a no use that many have indexes on it.
Yeah, is there over like in MySQL it's bad to do that, for example.
Yeah, I don't
Too much
know.
overhead.
It's probably differently bad, but like obviously like if you have, well, first of all, there's a limit on the number of indices they'll let you create. I think it's like 64 indices per collection, so you can only go so far. But second, it slows down writes. So every time you do a write, you have to look to every 64 indices or however many indices you have to see if you need to add that document to the index. So it slows down writes, and obviously it takes up disk space. So like disk is cheap, but it's not so cheap that you just want to be totally complicated with your indices.
Can Mongo use more than one index per?
No.
I guess I can call it a query or a command.
No, you can't. It only uses one index.
Is the index like a lookup into the main, or is the concept of a covering index where the index itself you can add?
Yeah, they added covered indices in the last release. But so yeah, if you're only selecting the columns that are in the index, it will go to the document. But so yeah. Yeah.
So it can only use one index at a time, then I assume it has sort of indexes on multiple fields in the same index?
Yeah, you can do compound indices.
So then you might have a couple of combinations of similar fields in different indices if there's a lot of similar queries.
Yeah, and also sometimes you need indices for sorting too. So if you want to do something like search for content type sorted by last updated, you probably need an index on content type, comma, updated, descending. So you can do, common indices definitely are useful and necessary in some cases. But yeah, we'll only use one. So I think I opened up this ticket, something like implementing index intersection, because Solr does this interesting thing where there's no compound indices in Solr, but they manage in Solr to do index intersection really efficiently. So you can do things like search for content type episode title equals whatever, even though you didn't tell Solr you're going to do that. And it does it by using skip lists or something. You know what that is? Like basically, they're taking advantage in Solr of the fact that their list of hits in their inverse index is sorted in document order. So basically, what they do is they jump. So they have these skips ahead. So you basically, if you're searching on title and content type, it basically starts and looks and says, oh, well, title's probably more selective than content type, right? So you'll see like, oh, it's in document 1 and 100. So you get to the 100 and you say, oh, now I can go to my content type inverse index and skip forward till 100 essentially. So he does this intersection. But I think it does it based on the knowledge that it has to be sorted. Your I can't remember what to call this. It's like essentially your list of documents within your inverse index has to be sorted by something. The same thing for all the indices.
But you're doing a mass load of it, so it's getting it. It's doing that.
And Solr has this way of doing like if there's multiple kind of sections of your index, so it has to merge them. But I'm not sure how they're going to do this in Mongo. So we'll see. So what else do they have? Notes less to explain, slow query logging, indexing, and as I said, we have our DBAs manage MongoDB, and they're actually really into it. Like, you might. Well, I guess it depends on your DBAs, but our DBAs at least, I think people want to learn new things, and so this is just part of their repertoire now. they manage Sybase, they manage MySQL, they manage MongoDB also, and they're bringing all the expertise, operational expertise to the table that my application team doesn't really have. Like that, they know how to set up the monitoring, they know how to do capacity planning. They have all these skills that are really readily applicable to Mongo. Just that there's some ways you can think of it as there's less for them to do because you don't have to, like in Mongo, for example, you don't actually have to create a collection or a database. You just, the first time you query from it, it just creates it for you. So there's certain administrative commands that our DBAs do for MySQL that they just don't do in Mongo. So, and because it's schemaless, they tend not to know as much about the structure of the database as they do for MySQL because they're not managing the schema themselves. But a lot of the other things they do, they're still doing, and I think it's been really useful to us.
So what do they do for monitoring? I mean, what are they watching? Number of queries?
They're watching, they have monitors on the slow query log, they have monitors on the disk, they have they set up monitors on just CPU, paging, all the standard stuff.
Mongo doesn't provide anything like what MySQL provides, like enterprise monitor or something like that.
No, there's some basic statistics you can pull, but and I'll actually show you something at the end, a tool that Tengen built called MMS, which is like their cloud-based monitoring system. So remind me at the end, I'll show you.
Given that the schema is in essence controlled by the app developers instead of the DBAs, do you ever have contention in terms of it's harder to do capacity planning when you have no control over the schema? And
we kind of play it fast and loose. We kind of tell them.
I would think that's mitigated by the fact that when the database is broken, you don't have the application developers going to you, the database is broken, because you don't have as much insight into it, right? They're the ones there. So I would guess that there's that tension, but it's lessened by not having the other kinds of tension that we have now.
But do you try to over provision?
Yeah, certainly. Yeah, I don't know, have you guys, anyone deployed MySQL in Amazon?
Yeah, oh yeah, EC2, yeah.
How's that go?
AWS.
Sorry.
I mean, it's just a machine.
Yeah, but we've heard that, Tengen doesn't recommend that you deploy Mongo in the cloud primarily because of EBS, is that the performance of EBS is not predictable, that you can have your read or write performance is just...
Yeah, it's network-based storage, so it's...
And it's also, it's shared, it's not yours.
Well, if you get a big enough instance, it's effectively yours. But even so, it's network-based, so you have bandwidth cap. Yeah. So if you are, say, doing if you're logging something, right? You're logging clicks or something. Every time somebody clicks, basically you're halving your bandwidth, because if you're writing it to disk, that's half your bandwidth, and sending it is the other half. So
yeah. So it's we haven't tried it. So we need to build out our own hardware for Mongo. So it's I'd love to be able to bring up a new cluster in a day, but that's not the reality, unfortunately.
How much of your Java application that was running on MySQL you have to change to run on Mongo?
Well, we're just building new application.
Oh.
So we're basically porting our sites to this new system. We didn't try to keep backwards compatibility with the old system. Could you hold 1 second? I have no idea when people want to leave or anything like that.
Oh, well, if you start to see people falling asleep, we say that the user group runs from 7 to 9, so you've got more time. But if there are some points you want to make, you might want to hold off questions till the end, because I think a lot of times we're also asking questions that you then say on the next slide. So why don't we wait till the end to ask more questions?
Okay. So just briefly, I probably should have said this earlier, is that the way we use Mongo is that we built a Java-based application that sits on top of Mongo, and so Mongo is really just, we use it as a repository, but in terms of the brand's use of Mongo, both the tool that we provide and brand's grabbing data and all the administration interface, adding new sites and collections, is all done through a REST interface. It's built in Java. So it's a bit of it's funny because when we brought in Mongo, we actually opened up a training. So we basically let anyone from the brands come to a Mongo training. But then we basically told them, like, you can't actually have direct access to Mongo, you have to go through the REST interface. And they're kind of like, well, we want to get to play with Mongo too. But I think we felt basically that it was part of our job as the provider of the CMS was to abstract the repository so that, because we never know what's going to happen. Like, in 5 years, maybe Tangent will be out of business and Elliot will move to an ashram or something and we'll need to find a different repository. We don't want to have to rewrite all of our sites again just because we're switching repositories. So we've done that before. Like we've tied ourselves to existing technologies, existing languages, and it just creates a lot of pain. So we're abstracting it with REST interfaces such that we're trying to make the REST interfaces abstract enough so that if we do need to switch something in the future, sites won't be affected by it. So let's see, content model, we define an XML, I think I mentioned this, and we manage it by our REST endpoints. This is an example of what a content type looks like in XML. We have base media item attributes. One of the things to show is that we can, it's kind of like Java in that you can say that a type is abstract or concrete. You can also have super types, so we have content type inheritance and we have multiple inheritance content types. Fields can be simple, like short title. They can be links. You can annotate your any fields with things like, we annotate things like it's deprecated, or this is the group it should go in the UI. This is showing like a list of tags and so forth. So we also built like a little, if I show you an example. We've been building this HTML browser for our system, so you can look at, we call them schemas, so you can look and see like, here's our standard schema, and we also have schema versioning, so here's a version of the schema. Here's like an episode, and you can see an episode, you can see that it extends base show info and episode adders, and here's all the attributes and which content type it got them from. So that's what we have there. So in terms of tool support, we kept the kind of schema-driven tools that we had in our previous CMS. So this is a tool that we have called ISIS. It's a Flex-based tool, and it basically is what our web producers use to manage the content. You can do searching by content type, by keyword, and then you can kind of see how it's, you can imagine this is how this would be table driven. You basically just reading the content type and using some annotations to figure out how to group the fields. So here's how you view it, and then you can edit it and save it and publish it and so forth. So one thing about CMS is that, how many people here have built CMSs before? So one of the things that is typical for content management system is there's this notion of a publishing pipeline. So particularly with producer-driven content, where you have people entering stuff by hand, they want to review it before it actually goes live on the site. So we've implemented 3-stage publishing for sites. There's an authoring stage where content is actually entered, and then they can publish it to staging, and they can look at it, say on once it goes publishes to staging, they can look at it on stage.spike.com, for example. That's looking at that publish stage, and then they're looking at there, they can publish it to live, and then it would appear on www.spike.com. The way we implement this is basically just copies of data. So we have separate Mongo databases for each stage of publishing. When you publish content from one stage to another, we're basically just taking the documents and copying them. That's pretty much it. One of the things we're doing is I talked about scalability a little bit. Even though we manage the list of sites centrally, each of these databases can be in a separate replica set, and the configuration basically says which replica set to find that database in. So we can isolate, if we wanted to put live spike.com on its own replica set for isolation purposes, we can do that. So then all the queries would go there, and if you're doing something in authoring, so like doing a large import, it wouldn't be affected by the live spike collection wouldn't be affected by that. So this is kind of what it looks like. So you might have a shared authoring environment where you have content records and pushing to Site 1 staging, and then Site 1 live, Site 2 staging, Site 2 live. These all could be in the same replica set, or they could all be in separate replica sets. So basically that's just configuration. So there's a picture of that. The tool obviously helps you publish, so there's a publishing interface in the tool. So you can select content to put in like a publish set, and then you can publish all the content as a group from authoring to staging to live. So we have the way we actually do is we have one database for our global configuration. Our schemas, our stored queries, our site and stage definitions, and then a database for each stage of each site. And we put all the content in one collection. And the reason we do that is because, well, there's a few reasons. One is like sometimes people, remember I said that the content types are hierarchical, or sorry, not hierarchical. There's super types and subtypes. So it's quite common for someone to want to do a query across types. Like particularly in the tool, people want to do like find me content that contains the word whole. And they don't really care about the content type. They want to see series and episodes and tags and whatever. So by putting it all in one collection, we can do queries like that across content types really easily. And even on the site, they want to do this. Like we have 4 subtypes of video. There's like UGC video, show video, music video, and it's typical to want to search across all of them. So in Mongo, you can only search in one collection at a time. So you can't do a cross can't do an inter-collection query. You have to pick a collection. So we basically put them all in a single collection. So all the links basically between documents are intra-collection links, even though the content types may be different types. And we have lots of indices, mostly on the link structure. So there's basic indices are like things like content type and the words index, but then a lot of indexes are just like videos, like I want to find all the episodes containing this video or all the episodes in this series. So you're basically putting indices on the links themselves. There's also, Mongo has another cool feature that we use, which we're starting to use, called sparse indices. So that help you when you have collections that are of disparate types. So what a sparse index is basically, well, with a traditional index, if you put an index on, say, title, if you want to put if you would put an index on title, say, it will index every document in the collection in that index, even if there's no title in that document. So it'll basically have, so say you have like 1 million documents, 100 of them have titles. There'll be 1 million entries on that index.
About rare things.
Yeah, they'll be useless and they'll basically be null. There'll basically be a big thing for nulls, and they'll have 998,000 documents in the null place in the index. It's kind of useless. And furthermore, if you want to make that index unique, you really can't, because null is just another value. So if you try to make it unique, it only allows you one document with a null title. So sparse indices basically say like that null values are not indexed. So if you have an index on title, it will only put things on the index that actually have titles. And furthermore, if you make that unique, it'll ignore the things that are null. So you can create sparse, unique indices in your collections. So we're going to start doing that. This is just a picture showing what I'm talking about. So it's just showing that you can have a collection per content type, but we just put everything together. So data access. How do we do data access? Well, first of all, what are we trying to do? We're trying to abstract the underlying repository. We want clients. This is the kind of a key point. we want clients to be able to specify at a very fine level the shape of the response. And if you think about what our documents look like, they're hierarchical and linked. So we want people to navigate the hierarchy and also the link structure in a single request. And we want to minimize the size of the response objects. So we want them to be able to say we want the result to be as small as possible, and also to have people be able to say exactly which fields we want. And we also want to be able to protect the server from dangerous queries. So what's a dangerous query is basically like an unindexed query. So we don't want to just say like, okay, you can just send any Mongo query through, because then people could start querying on unindexed fields, and then our performance is going to go to hell. So we built something called JSON path. And the JSON is actually not for what's returned, although we are returning JSON, but it's for the way we specify the structure of the response object. So let me think of a better example. So I did a query for, it's hard to see, but I did a query for by type. That's one of it's basically a stored query. And I'm saying by type standard : series. And what I'm querying for is, sorry, it's hard to see. I'm basically saying select *1. So I'm basically getting all the fields of a series. So what can I do? Say I want only the language. I can say, well, let's do something more interesting. Say I just want the keywords. I can just get the keywords. That's basically a simple thing, but I can get a list of, it's not just a single keyword, I can get the whole list. But let's say I want something, remember if you might have noticed, there's also a link to videos. Actually, let me show you that again. Oops. I shouldn't demo things like this. I just let it roll. That's better. So this is just showing the links from the series to each video. But say I want to reach into the video to grab something else, grab something about the video. So I can do something like this.
Do you store video like files?
No, this is just metadata about the video. It's just so I said select videos : *:1. So this is basically saying take the videos link and then show all the properties of the videos that are linked to from the series. So that's showing all of them, but I can just take out and show, if I just want to see the title of each video, I can say something like that. So now I'm just getting the list of just the titles of all the videos linked to from the series. So you can basically navigate the whole structure, and you can make that select statement as complicated as you want to pull in as much or as little data as you want. So, this is basically our REST interface for data access. It's JSON path.
You send that full. I mean.
Yeah, this is actually
the REST is the query string.
Yeah.
The queue.
This is the query string. It's the whole thing. What's that?
Not very REST.
Well, no. I'd say it's our JSON over
web service.
HTTP. What's that?
It's a web service wrapper.
Sure. we're not sticklers. Site launches, what have we actually done with this system? The first site launch on this system back in February was Spike.com. So Spike.com currently runs off this CMS, where we launched also some Nickelodeon international sites. We'll be launching Nickelodeon Spain, I think, in a couple of weeks. And then big launches towards the end of the year, we're going to be launching game trailers and Comedy Central. And then soon after that, The Daily Show and Colbert Report. And I think also Nick.com will be launching. And then the ring up the rear will be the music sites like MTV and VH1. So it's going pretty well. We're having really good success so far. I just wanted to show you.
This is the monitoring stuff.
Yeah, I just wanted to show you the monitoring stuff before we go. So. Come on, don't be mean. There we go. So, this is basically a list of all of our hosts. I shouldn't probably put this up here, but
difficult to remember.
We're all old. We can't read that. It's too small. Yeah. No, actually, it's not a high enough resolution for the video camera, but I'll blur it out.
So this is like our list of hosts. So here's our live replica set, and then
You certainly shouldn't post the IP addresses.
That's all right. It's all hidden. So this is like the op counters for our live replica set. So you can do. This is showing. It's basically like. You can do things so by default it's hour. You can see all your op counters and you can see things like basically queries per second over the last hour, average over an hour. But then you can also go into different ranges. So if you want to, I can zoom in on the last day. So it shows that we're doing about 200 queries per second, average over an hour. You can go to a day.
And it was MongoDB guys who wrote that, not you.
Yeah, we didn't write this. Tengen wrote this, and they're hosting it. So basically, we install an agent on our server, and they're basically reporting back to the mothership like once a minute about all of our replica sets, and then putting it here. The nice thing about it is that if you are a commercial support customer, or even if you're not, I think they're actually going to open this up publicly, even to people who are not commercial support customers. Like when I have a support issue, I can just say. I can just show them what's here, and they can look. They can see what's happening on our machines. So let me just show you a little more about what kind of things you can see. This is a secondary. So you can see things like all your op counters, how much memory you're using, your resident memory, virtual memory. How many connections, your replication lag, how many cursors. So you can put basically, if you asked about monitoring, basically all of these things here are exposed at the shell. So we can put our own monitors or alerts on any of these things. And we do. So how many page faults, all sorts of stuff. And there's also, I think, let me show you something. So they also have hardware monitoring using the Yemin plugin. So you can look and see what's happening in your disks and CPU and all that stuff. So there's a bunch of information here that's you can use for yourself and also for communicating with Tengen. We use internal monitoring tools too, like we use Nagios. So we have our own alerting and monitoring system as well, but this is kind of, it's a lot prettier than.
It's from the people who wrote MongoDB, so they know what to monitor.
They know what to monitor, and they also use more modern web interface stuff than I've seen in some other monitoring tools. Like, we use Cacti, and it's a dog. Like, I can't even run it from home on my VPN. Like, it just crashes out on me. So, we might not use it the best way. But this performance is really good, and the dynamic nature of the graphs is really nice.
And if I'm not mistaken, I think they actually use MongoDB underlying. I know that in general,
Yes, they do.
they are a company that eats their own dog food. So,
Yeah, so all this stuff is stored, all that information is stored in Mongo. And I think they wrote it in Python, and this is all, I don't know what graphing stuff they use, but easy to find out if you...
Do you pass the queries directly in from the request? Because you said you protected against, so do you like unwrap that JSON query and say, okay, are we going to allow this?
So if you look at that query, here's the query, here's the where clause essentially.
we can't really see that
Oh, you
because of
can't
the
see?
top of the
Well, when you
screen.
click it, you can. When you click the edit.
Yeah, when you click it and you start to edit it, it scrolls down a little bit.
Resize the browser, just make it a little bit smaller so that we can see.
Okay.
Yeah.
Yeah, there we go. Oh, look.
Let's see.
I think when he was talking about protecting, he was talking about protecting against slow fields.
Yeah, you had said something about like don't let it run if it doesn't run if it doesn't run.
Oh, that's
an
something
index
you can, we don't use that feature though.
Yeah.
So basically, if you look up here, it says where and then by type and then standard series. So by type is basically a named query. It's like you think of it as a stored procedure. We have a little object in the database, we have a collection in the database which has a collection of all these queries. It has a name, a list of parameters, and what their types are, and then the actual Mongo query that will be used to run this query. So this query is a simple one. It would just be content type : and then you grab that, and put it in. But by having that, we know what queries people are using, so we can take steps to make sure that all the queries are actually indexed. We'd rather not have to do this, but it's kind of like one of those trade-offs where we just feel like if we open it up completely, we would get ourselves in trouble.
And do you offer that? Can folks download that that application? This is something you guys wrote, right?
Which part of it?
This
JSON path?
yeah, the JSON path.
No, as far as we didn't open source it.
Okay.
If people are interested in it, they'll consider it.
Right, so a couple just clarifications. So when you showed a chart earlier about replication lag.
Yeah.
Right. Is the exception that you have replication lag, and that typically if you pull up the monitors, they're all at 0 while you replicants, or is it? You just sort of live with the fact that you have a couple hundred seconds replication lag.
No, you shouldn't. Under normal circumstances, your replication lag should be a few seconds.
Yeah. Okay. So essentially,
I think it pulls. So.
So, and two more questions for you.
Yeah.
Save them for the end because you're done.
Can I get that in writing?
So the big advantage to this over like a Sphinx or Solar or whatever is that it's live. The writes that are happening to it, I'm either rewriting the whole document or just a piece of the document all the time, as opposed to pulling it every minute or 10 minutes or whatever. Is that one of the big deals? Do you know, just that aside, which is a great benefit, is it actually faster? Is it actually faster than Lucene or Solar or Sphinx?
We didn't benchmark it because it's not a fair comparison, because one of the things we're doing in our the JSON path interface, it's not just completely passed through. We're also applying some business logic at that level. So, and there's a whole application in front of it, which is written in Java. So like raw query performance of Mongo versus Solar, it's probably pretty similar. The thing is, I think Solar is a little more consistent in terms of like in Solar, it's like everything there is indexed in the same way. So it's not like choosing, like it knows what index, it always uses the index on the thing you're searching on, and if you search on multiple things, it's doing index in each section. So its performance is pretty consistent.
The third question I had is in terms of concurrency, right? So these things are indexed properly. Is there contention when multiple different clients are coming at the Mongo database each doing a query against the same index. Does it ever happen that the indexes like fight with one another and end up in some sort of a deadlock situation, or?
No, there's no deadlock. The contention, there's a couple of ways contention can happen. One is just disk thrashing. So if you have multiple queries using two different indices, say, or two different parts of the same index, and there's not enough RAM to hold them both, and you're swapping back and forth, then obviously you could be in trouble.
I guess what I'm saying is, what if you have 20,000 people all coming in doing a search, which is hitting basically the one index, and if you do it before they had the slaves, they were all hitting the same instance. Have you ever seen problems where all of a sudden the performance just dies?
No, I mean, there's going to be some. No, we haven't seen performances die from normal queries. Obviously, if you pump enough query volume at something, like you're gonna run into some bottleneck. So if you have, even if you have 6 replicas, 6 secondaries, if you throw millions of clients at it, essentially you're gonna probably will. And let's say you're not RAM constrained. Say your whole database fits in RAM. Eventually what will happen is you'll have network saturation. So you'll just saturate your network pipe, and then you'll be hosed.
I've done some load tests on when I was testing MySQL cluster, and ended up that we started to run out of we ended up testing hundreds of thousands of connections and whatever, and we actually ended up hitting the bottleneck of the kernel limit of 10,240 TCP connections at once.
Yeah, that'll happen.
Yeah.
You want to bump up your U limit probably. So what else can be a bottleneck? Obviously memory, like disk can be a bottleneck. But what we found is that Mongo is so fast, especially when you're in RAM. It's not just Mongo. It's just it's just fast enough that we can't even stress out the primary. We could probably just have our primary handle everything and not even use our secondaries.
Do you find that the servers that you buy, the actual physical hardware that you buy, are you focusing on buying a lot of RAM? Does it matter if you have 4 CPUs or 8 or 16 or whatever?
I think your mileage will vary based on, I would never say buy this hardware, because it just totally depends on your application. But
it can leverage the CPUs. I mean, I'm asking because when I came to the 5.5,
yeah, it can totally leverage more CPUs. But what we're finding is that we have I think 12 core boxes, and we're at 3-4%.
Yeah, if your content, I'm looking at Spike right now. The bulk is not the back end searches for their content; it's the actual content itself, the image sizes, and the amount of stuff that you're pulling in from different places, Facebook and all that. So they can optimize and throw lots of money to get it that much more faster, but that's not really gonna, I think, affect their business as a.
No, we want to have low latency on the queries when they do happen, just because when you do have to go back for origin and your TTL runs out on Akamai, you want to be able to serve the page relatively fast. But 99% of your hits from the page, 99.9 are served from the edge anyway. But you do want to have page generation fast, so that because you do sometimes have new pages, you want to. When new content comes up, you want it to come up fast.
Do you have a team that focuses, your platform, so you're providing the service?
Yes.
Is there another team that analyzes content that people are putting into the system and optimizes or sets up your Apache or Light? What are you using for your...
What is our job application? What are we using there?
Yeah, what are the web servers that you're using?
We're using, for our job application, for the content service layer.
Yeah.
Both in Java, we're using Java and JBoss, and then Apache and Chrome. I think for JSON path, we're putting Squid in front of it for the reverse proxy cache. We just have a pretty short TTL on those feeds, maybe 1 minute, so we use Squid for that. What else?
Kind of a fundamental thing I'm trying to understand.
Yeah, sure.
So but in Mongo, essentially, still is the CLOBs still is what the basic document is. So because you said it doesn't really understand what the schema.
Yeah, you can think of it as think of it as each document is a JSON document, but but stored in a not text. It's stored in some binary format.
So when you request a document, Mongo has to give you the whole thing, but JSON path reduces it to the pieces that you requested in the query?
Oh, no, Mongo can give you pieces as well, but it won't follow links for you. So when you query in Mongo, say you have a link from a series to episodes, it'll give you the value of the links in the series, but if you want to get some information about the episode, you have to follow the link yourself by doing a subsequent query. So we have like application caching, so we'll cache frequently accessed documents so that we don't have to go back to Mongo. It's also relatively simple in Mongo to, like, you can pass a list of IDs, so you have a list of links to, say, you have a list of links to 30 episodes, you can basically do a query like, give me all 30 episodes at once. So, and then from there we can, if what you're asking for from those series is you just want the title, we can, in the Mongo query, we can say, just give me the title.
Oh, so you can set up the JSON path to give you follow some links if they're ones you're prepared to follow?
Yeah, so we can follow any link they ask for, but, and we'll just use application caching to if we already have that title of this episode cached, then we'll just grab it there. Otherwise, we'll go back to Mongo.
So, I mean, there is a schema, it's just not required. So, for example, if there's a show that doesn't have a video link or doesn't have a title, it doesn't store a blank thing for that. And you're not required to have it, right? And you could have like more than one. Is that true to you, or?
Yeah,
because it is structured. I mean,
it's structured, but there is no schema in the sense of like you can, in a single collection, you can put any JSON document, collection of JSON documents you want. None of them have to have any of the same fields.
Right, they don't have to be, and they don't have to be related to each other at all.
Correct. It would be hard to index that stuff if they don't have any fields in common. But if you're just using it as like a logging system or something, and you're just logging, like, I don't know, query parameters or user agent or, well, you'll end up having the same thing. But you don't, like, in principle, you don't have to.
So, the previous system also worked on MySQL, right?
Also worked on MySQL?
You said that the first system started with Sybase?
First one was Sybase, so it was ported to MySQL, and then the second system also started on Sybase and was ported to MySQL.
Just a question, concerning the XML and what you're doing now with JSON, is that, you get this functionality from like Oracle XMLDB?
You might, I mean...
just storing XML, be able to query based on XPath functions, stuff like that. Would that, be similar functionality?
Perhaps, yeah. We don't really use Oracle, and again, we don't...
Naturally. Price is a factor.
Yeah, so, Mongo is open source and you can deploy it. You don't have to pay anything for it if you don't want. Commercial support is like, I think maybe $3,000 to $4,000 per server.
Per year?
Per year. So it's pretty low cost, and I think a lot of people don't, it's up to each organization to decide whether it's worth it to them to have commercial support. For us, it's definitely been worth it.
Instead of commercial support, or in addition to it, some people choose to go to the MongoDB developer days. They are not developer days. The MongoDB conferences they have, and they do have office hours.
There's meetups. There's
I was doing a transition though.
Yeah.
Into that. Do you have a slide for the passes that we were going to give away to Mongo Boston?
I don't have a slide, but I did. I just have a link. Oh, so if you want to contact me, this is my email. Yes. Yeah. So October 3rd, there's Mongo Boston. So they basically do these traveling tours all over the world, and this is the second one in Boston. I went to the first one, and I guess it was August last year, and I had never used Mongo before.
And here you are speaking about it. So you can go in October, and in next December you'll be an expert.
And if you go in October, you can hear me give this talk yet again.
How long have you been doing Mongo? Like at MTV total?
I would say a year.
Okay.
What's the development site like? Is it still actively being changed, or is it
Mongo?
slowing down a little bit? Or, yeah.
No, it's not slowing down.
Speeding up.
There's a feature backlog. As I've said, in other like successful products tend to get more complicated and ask for more and more feature requests. So of that nature, I think Mongo's been very successful.
Website has to pay now.
What's that?
You just got
Yeah, geospatial stuff was released today.
Oh, new geospatial stuff?
Yeah.
Yeah, 2.0 was, Mongo 2.0 was just released today with over 400 Jira issues closed. They typically do a major release every like 4 to 6 months maybe. So we just upgraded to 1.8 like last week, and now 2.0 just came out. So we're already stale. No, I think there's a lot of new features people want. Like some of the things we'd like, for example, is we want them to do faceting and full text search, so that we have some better full text search options without building our own stuff or having to use Solar in some certain cases. Like it would be nice if for our tool, like our ISIS tool, that we could just use native Mongo full text search for that, for example. There's a ton of feature requests, just like you name it, people are asking for it. But overall, I think we've been pretty happy with it. So, I recommend try it, give it a whirl, download it. If you're interested more, I think there's also a meetup. I think I mentioned that just a minute ago. So if you just look on the meetup site, there's a Mongo meetup in Boston. We met at the Microsoft Nerd Center for the first time last month.
So is there anyone that wants to go to Mongo Boston? You can see it's not a very expensive conference. It's a day-long conference. But we do have a few free passes to it. So, if you wanted to save $20 today.
The price dropped. It was 50 last time.
Oh, that's not true. Was it?
Last year it was $50.
Then maybe they probably got more sponsors this year.
Yeah.
But
Is that what day is that? That's like
Monday.
I think
It's a Monday.
October 3rd.
Excellent. Maybe I'll go.
There you go. Well, contact me and I can get you a pass. Is there anyone else that wants to go?
Maybe. Mm-hmm.
Send me mail.
Mm-hmm.
So
Too many of you will have to
that's
raffle it.
yeah, that's probably enough. But no, I'll make sure to let you know before the end of the day tomorrow, which is when the price goes up to $30. So that if we can't get all of those passes, we won't make you pay an extra $10 to go. But
Where is
going to
your group out of? Is it out of New York or Boston or?
Oh, my MTV.
Yeah.
Oh, so it's out of New York. I used to live in New York and moved up to Wayland like 5 years ago, and I work remotely. But most of the software development is New York, and some there's a bunch of groups in California and international groups as well.
yeah, there is a MongoDB group. They just started though. They had one in August. They don't have another one scheduled.
Where it's going to be? Is that in Cambridge?
Where is this one?
Where in Cambridge? I think it's at the Nerd.
Yeah, I think it's at
Nerd
Nerd.
Center.
Yeah, it's at the Nerd Center, which is right over there or something over there.
Yeah, very close.
It's not easy to find. All right, any other questions? Thank you so much.